Great, Bob, you have the first item.
Yeah, so I'm not going to share my screen. You can all read the issue, but I don't know. Yeah, it was with Craig. I was discussing database transaction time, like real database transactions.
I can barely hear you, Bob. Could it be that your microphone is being blocked?
I don't know how to change that. Wait, let me see.
You're louder. You're becoming louder.
Yeah, it's the auto adjusting was a bit slow, it seemed. Better? So yeah, I was discussing database like time and SQL query timings with Craig in a merge request, and then I noticed, hey, these things have a feature category label. And I was wondering how, like, if and how and we should add those to the error budget. So we have threshold sets set for queries, how fast they need to perform. And if an endpoint is performing slow queries, we could ding them for it. But the question is, like, if we do it like it is now, then that means that a request that does 1,000 super fast queries would get a thumbs up because it's 1,000 super fast queries, which is not what we want. So that's why I brought it up. Sean, if you are on the call, I can't see you, but could you explain what you've written?
So if we're using histogram buckets, we don't actually know, like we know if they're satisfied or not satisfied by the timings, right? Like we know if the timings are good or bad. But I was thinking another way we could do that is to have like a counter of database seconds consumed by this whatever, and say that you have a budget of
like the field in the logs.
Yeah, so you have a budget of X seconds per thing that you're doing, and we could just say if you're exceeding that budget or not.
It sounds almost like this is orthogonal to error budgets.
Yes.
Like if people have a feature that's fast, then we don't care what it does as long as it's fast. And if we want to say that the database is some sort of resource and we want to give people quotas of how much they can use the database, that's a nice idea, but that doesn't sound like it's error budgets. That's more about stopping people from using the database too much.
Also, surely what you can do is you can have a measurement of, I think maybe this is what you were saying, so excuse me if I'm paraphrasing you, but it's basically a histogram of the sum total for the request, right? And then it's just a normal aptX after that. So you get two. You get
that's what Sean was suggesting.
Yeah. And then one is kind of like the one where we measure each request. We actually attribute that to Petroni and not to a particular team because it's a way of kind of judging the database. But this one would be not Petroni. It would be the actual.
Yeah. Then it would be
feature category.
Yeah, another feature category. Then I would like record it next to the Puma ones, but with a different component. But the way we record it is not so important. It's how I like the idea of using a separate thing. And Jakob, to reply to what you said, it's a way of like seeing if people are nice to resources. I think of it like I think Andrew mentioned that before. Like it's a way of having mechanical sympathy things included in those budgets. Like then mechanical sympathy becomes how nice are, like if you're doing 1,000 queries in your request, that I think that would currently show, I don't know, do we have mechanical sympathy for the database?
I'm just not sure
Sorry, go ahead, Jakob.
I was just going to say that if something is slow, like the users don't care how much something uses the database. So if something uses the database in a bad way, it will show up in from the user perspective. But so we complicate the system by having. So we want to have the teams make good decisions about what to focus on, and we can have a simpler model where we just say this thing is slow too often of the time, so something's wrong. Or we can have a complex model where we say you're using the database a lot, so maybe you're doing something wrong and you should look at that.
Well,
But
the simple model we have now is what we have now. That we have thresholds set on the request, and if they complete within a second, you've got thumbs up. But you could still do a lot of queries in a second.
But do we care? Why do we care?
Yeah, I see where you, like, basically, the whole thing with the service level monitoring is you're measuring the service quality from the user's point of view. And so maybe we shouldn't be confusing and that's where error budgets come from. And maybe we shouldn't be confusing this with that. Is that another way of putting what you were saying, Jakob?
Yeah, that's one way. And another way to look at it, and I don't have a good view of the bigger project, but the way I understand it, we're trying to make a big step in adoption of error budgets across the organization. And if we can get a good result from people, if we can have a simple system that gives useful signals and that changes how the whole organization behaves, maybe we should start with that simple system and not mix more signals into that model, but we don't have to yet.
I think also with the error budgets that we're putting in front of people at the moment, by and large, a lot of the stage groups are seeing red bars. So whether or not we add the database information now, it would probably just make the red bars even redder. Like it would make it worse. So I think that we've already given them quite a lot to focus on and quite a lot of things that they can improve. And it may be that in future, once things are more green, we can then decide, right, how do we add in the database information into the mix? But it feels like we're either going to make this a bit too difficult for the stage groups to actually adopt right now if we make it too complicated.
I think it would be easier to track down, because if you like, the whole thing all comes down to what was good and what was bad, and you get points to score and points to lose. If you've lost points on database time and on request time, then you know what to look for in other places, like where am I executing too many queries. But we can start with what we have for sure.
I think that's a different part of the process, because the error budget tells you something's wrong, and then you need to look at your metrics to see what's wrong and what do you do about it. But
it's specifically not cause based. It's symptoms, right? And we don't want to kind of, that's a symptom rather, that's a cause rather than the symptom itself. The symptom is the user's having a bad experience.
Yeah, it's symptoms versus cause. That's exactly what I'm saying. Yeah.
Just one other thing is, there's also, like, in addition to that, which I think is a really, really important point, but also it kind of, there'll be two things contributing to that error budget, right? Because then, so if you imagine a request coming in, and there's one request that's really, really slow because it goes to an external thing, or it just spins, it just for I = 1 to million, it's going to get a tick on the, it didn't make 2 seconds worth of database calls, SLI gate, right? But it's still, from the user's point of view, it's still rubbish. The user doesn't really care whether it was the database or because someone put a for I = 1 to million. But on the one, if you look at it overall, they will get like 50%, and on the other one they will get 0%, right? And that's not really fair, because the user doesn't, in both cases it was a really slow request, but we're judging the one by, because it was a database problem, by two things rather than one. Does that make sense?
You're diluting the strong signal that the user had a bad experience by having this conflicting signal that the database was fast, which the user doesn't care about.
Yeah, because if it was like external HTTP requests and we don't have that covered by this, then we ignore that. And so, they only lose 1 point for that because it wasn't the database, which is the thing that we're watching on this. So I think it's better, as you said, to keep it simple.
But we do have SLIs that are not user-facing, like they are user-facing, but they're not. Like Gitly is one of them. Like the RPC speed that currently gets attributed with the Gitly feature category or whatever.
So with Gitly, we tend to, the way I see that is that the user of Gitly is Rails or Workhorse rather than an end user. So it's kind of a little bit different, the service consumer.
If Gitly, time spent in Gitly is part of the error budget right now, I think I would say it shouldn't be for the same reasons.
It is, but only for the Gitly group. So
yeah, okay.
the Gitly,
they get judged, yeah.
Yeah, but their service fair. Consumers are Rails.
Yeah,
and
their
not,
users, exactly. Yeah.
Yeah.
I'll close the issue for now. Thank you for the discussion. Somebody else have something on the agenda?
Before we leave the topic, just as a brief tangent, I think it's maybe worth mentioning that if we do have consumers of database connections that really do go through a churn of just making the numbers up, 1,000 requests, 1,000 connection leases per incoming request, that is a system-wide degradation class of event, and I don't think the chargeback should necessarily be. We're not really talking about chargebacks, and this doesn't strictly fall in the category of error budgets, but it does fall in the category of overall AppDex jeopardy for the system as a whole, not necessarily for the particular component that's consuming that high churn on lease event. Does that make sense?
If that happens, we have a problem in general.
Exactly. It would have a knock-on effect for all of the consumers that compete for that connection pool. Do we have a reason to suspect that that's happening now?
I think it was just being used as an example, though, Matt. Like what the
I think
point
so
was
too.
that,
I agree.
Yeah, I
wanted to find out if someone has seen evidence that this is happening, because if it is, that's something we should look into as a separate topic.
So certainly on Gitly with the Gitly N+1s, we used to have like 5,000-6,000 gRPC requests, and like luckily over time with lots of work we've got that down. I was just looking through the mechanical sympathy alerts, and I'm not sure whether we're below the threshold or whether we don't have an alert on that. But I'm going to check after this, because then we could look in that channel and see what the worst case N+1s are. Because I don't see it here, but I know that there's some that are like pretty bad.
Gotcha. Okay.
Yeah.
Cool. Thanks.
So I put something on the agenda, and to talk a little bit about possible future project I'm working on, which is this thing with the gRPC bottleneck. And I'm not really sure what to talk about because I didn't really know what audience to expect. I talked about it in quite a lot of detail with Matt last week, but that was only with Matt because we were the only two people in the call. And I don't know if people watch that call or if other people are, how up to speed other people are with what we discovered. So I can talk a little bit about what we discovered or give a chance to ask questions about what we discovered. And I can also talk a little bit about some of my ideas for how we can actually do something about it. But I'm not sure where the interests of the rest of the call, of the people in the call, lie. Does anybody want to hear something more about what we discovered or have an opportunity to ask questions about that?
I read the thing and I was kind of surprised that gRPC is that much overhead. It was pretty cool to read. And I was kind of curious at what you intend, but I think you intended to show now is how you bypassed it. Okay,
so what we can do about it. Okay.
Yeah.
I think I'm going to briefly talk about the problem because I see it's been mentioned in the infrastructure group call and it's getting more attention, and I'm still trying to figure out how to present the problem to people and what because there's different angles to it. The way I framed that issue 1046 is we hit a bandwidth limit, a network bandwidth limit, which is sort of about how this affects users ultimately. But there's another angle here, which is to understand what we're doing that is so wasteful, and I made that less. I think I made that less prominent in the way I presented the findings. But if you're coming from a technical angle, that might be more interesting. So, just how much memory we're wasting, or how much memory allocations we're wasting, and So I want to briefly talk about that, I think, just so that we're on a technical level, we're on the same page. Wait, where did I put that issue? Oh, come on. There it is. Okay, I'm going to share my screen. So like the real data, if you want to have in-depth data on the findings, there's this one thread on issue 1041 where I collected data for the different scenarios that I summarized in the table. And the one I want to talk about is the memory allocations. So I have, this is a capture of memory allocations when, which one did I just click? That was the first one. So that is Gitly, regular GitLab when there are no cache hits, and then we're stalling on the CPU. Basically, we're hitting the gRPC bottleneck here. And this is a 30-second profile, and you see here 100 gigabytes of allocations. And this is absolutely horrible. And I didn't really make a very strong point of how horrible this was in the other issue, but because I was sort of thinking, if you think about how this is supposed to work, then 100 gigabytes is horrible. But I'm not sure if everybody understands or has the same view of that. Why is 100 gigabytes of allocation horrible? If you want to transfer data from one thing to the other in Unix, you need a buffer, and you say that at minimum you need a buffer, and you say to the kernel, please read some data into this buffer. Then you want to write it somewhere else. Then you say to the kernel, please write the data in this buffer to this other thing. But you can reuse that buffer. You can do that 10,000 times in a loop and reuse one buffer and never allocate a new one. That's how it's supposed to be. But what happens with gRPC is that we read into a buffer, and then we want to send it out as a gRPC message, and then gRPC allocates memory 2 or 3 times for the data in that buffer, and then sends that out and throws that memory away again in a loop. So 10,000 times you are allocating memory to hold a copy of the buffer and throwing it away. And if you had to write this from scratch, you would never allocate those extra copies. And if you're going at full speed, then you see these kind of numbers where I had to divide it down. This is 3 gigabytes per second that you're allocating. And you only need to allocate 32 kilobytes once in the request. And then you can transfer as many gigabytes as you want. And you can see this if I scroll down the thread to, let's see. So the alternative, like the toy implementation, if I look at the memory profile there, it says 7 megabytes, 7.5 megabytes. And a lot of this is done by the profiling system because the profiler is running. So almost half of this is the profiler. And this is the difference between a constant amount of memory allocation once per request and memory allocation proportional to the amount of data you're transferring. Does this make sense? I just wanted to, I don't know if I highlighted this enough in the original presentation, just how crazy this is. Yeah, so that's one thing. And then the other thing I can talk about a little bit is sort of a walkthrough of how the toy version works, if that's interesting. Okay, I see some nodding. Let's see. I wanted to do this. Let's just do it in here. I'm already sharing this. So the easiest way to start, I think, is to look at the client. So this is the program that emulates Workhorse. And this is the function where we handle post upload back, which is the thing that transfers the bulk of the data. And what happens is that it calls this magical transport call function, and it says it wants to do post upload back. Now in this toy, we cannot say what repo we want to clone. It always clones the same repo. So in real life, this would not just say I want to do post upload back. It would also say what repo it wants to clone, but that didn't matter for the toy. We get a net connection object. This is some stuff in case the client compressed the inputs. But really all that happens here is that we take the HTTP request body, we copy it into the connection. So this allocates 32 kilobytes to do the copy, no matter how much data you're copying. Then we call close write on the connection, which signals to the server that no more data is coming. And then we copy the data from the connection back into the response body. So that part is that straightforward? Let's go to state like this is simple, but I don't want to show. Okay. So then the next question is what happens in the transport? This is how I wanted to talk you through it. So transport has a function call. It takes as arguments a function that can create a connection and the request, which is just some bytes. So that thing is passed in. So first here we get a connection. And then it calls this send frame thing and it sends the request. And it needs to obey a deadline when it does that. And then it reads one frame back on the connection. And it compares that to a magic string, response OK, which is literally the letters OK. And if it sees that, then it gives the connection back to the caller. So then we're back in the program I just showed you where we start copying. And if at this point we did not get the string OK back from the server, then we would have returned an error and that other thing would have returned immediately. Still with me? So let's send, then let's look for a moment what send frame and receive frame is. So what that does, I decided like, let's say a frame is, I needed some sort of chunk of data and I thought 1 megabyte is enough to fit like the request metadata of a gRPC call. Like if we have GitLab feature flags and authentication metadata, correlation IDs and whatnot, hopefully that all fits in 1 megabyte. So first we check it's not more than 1 megabyte. We set a deadline here so we don't stall. Then we write the length of the frame. So I say the frame is 12 bytes in this case. So first we write the number 12 in binary on the connection. And then we write those bytes on the connection. And then we remove the deadline again. So that's all that does. And the opposite reads the length header from the connection into a 4-byte buffer. And then it allocates a new buffer for the frame we're receiving. And it reads that many bytes into the frame and it returns that to the caller. So it's just exchanging a blob of bytes with a length prefix. So that's the client, if I still have you with me. And then the other side is the server. So let's look at the server for a moment. And that was in this file. So the server, it has a listening address. And I put that in a global variable. So what does RPC server do? It creates a TCP listener just with the Go standard library. And it creates a transport server with a handle function, and it tells it to serve on that listener. We'll look at the transport server in a moment. So the handle function receives a session and a request. And so the requests are those bytes like post, upload, back I was sending in. And it looks up those bytes in a map. And if it can't find them, it says it's an error. If not, then it tells the transport that it's accepting the connection, and then it runs the handler function on the connection. And then these handler functions are, they look just like the opposite side. So you have a net connection object. We create a git command, and we say standard input is the connection, standard output is the connection, run the command, and then the bytes get copied. Still with me? So then I want to show what the transport server does, which is the other main piece of the puzzle. Go back to this file. So that was okay. So what's a server? Server, I don't know. I decided it can have multiple listeners, but it only has one in practice. It has a function that is the handler. And yeah, honestly, the stuff with the listener is kind of, please take my word for it that this is boring. We're just accepting connections in a loop, and we're running them in a Go routine. And what we do in the Go routine is that, so we have a connection, we haven't read anything yet. So the first thing we do is read a frame, and those are the request bytes. And then we create a server session object, which holds the connection and the deadline. And then we call the handler with that session object in the request. And if the handler returns any sorts of error, we call reject on the session. So what is the session? The session holds the accepted connection. It remembers if it's been accepted and remembers the deadline. And so the server can choose to accept the connection. And when it does that, that is when it sends back the OK frame. Like the magic bytes OK gets sent back when the handler code says, OK, I want to do this connection. So the handler also has a choice to say, I look at this request, I don't know what I'm doing, what I'm supposed to do with this, I reject this. And what rejecting just does is it takes an error and then we encode that as a string. So it says error space and then the error string. So it's just a very simple format, and we send that back. So that's how these pieces all fit together, and that's the foundation of the toy thing that I reported the numbers on in the issue. Maybe I should. I could show you more, but I think I've talked enough. I should stop here.
So the interesting bit is how you'd fit that, because the interesting bit is now where you had the case, like if I get this, I'm going to do this Go thing. And you want to fit that, you want to find a way to do that in Gitly. Is that
that's one of the interesting bits. And
like that's the thing that I was curious about. Like, what's the plan?
Yeah. Okay.
What's the plan to make Gitly do that instead of replying?
Yeah. Well, there are two pieces to the plan. One that I didn't just show you because I think it's not polite to everybody to take that much more time. But one is that this basic thing I showed you, you can enrich that so that it carries all the metadata of a gRPC call. So you could say, here's a method, here's a protobuf binary encoding of a request message, and here are the headers that include authentication, correlation ID, and whatnot. So you can build this. This is a layer, and you can build another layer on top of it that is sort of pseudo gRPC.
So you want to make the gRPC the thing that Workhorse starts with. You want to wrap the gRPC thing in something else that you will send off and then reply with something that looks like gRPC but isn't.
Yeah, but isn't, because in the middle of the gRPC call, we then pull out the TCP connection and we use that instead of gRPC, because otherwise we're no better off than we were before. But the reason I want to wrap it in a sort of gRPC-ish layer is that we can use middlewares, like we can get all our logging and Prometheus counters and authentication that would all work exactly the same. Correlation IDs, tracing. We could reuse all that because we already built it for gRPC, and I think I can get it close enough to gRPC that we can reuse that stuff. So that's one. And the other piece is, how do we make a connection? And there the funny thing is that Gitly already does something creative when prefect connects to Gitly. So prefect can start a connection that is not gRPC. And Gitly has a way to hook into the gRPC library and detect that the connection is not gRPC and treat it differently. And right now that is used only in Gitly for something, it's called backchannel, and it's used specifically for prefect stuff. So for coordination, when there's a write and the write needs to be replicated, so then they need to talk back to prefect and say, we're doing a write, or is there a quorum, or I don't know the details, but that's what it's for. But that thing already knows how to accept a non-gRPC connection. So we can generalize that and say, well, okay, right now you know one type of non-gRPC connection, which is a backchannel connection, but we now have a different type of non-gRPC connection for this new thing that I don't have a name for. And then we do that. So that way we could have it be part of Gitly. I don't know if that was convincing. I'm trying to write this all down, and I want to be able to convince everybody that this is feasible with a written proposal, but it's hard to figure out how to present it, and that's why I wanted to talk about it here and see what questions you ask. And
so my take on this, having spoken to you previously about it as well, and is it kind of feels like at the time when the decision was made, and I was around with that as well, it was like, hey, we need a protocol for communicating. There's this thing RPC, gRPC, let's use it. It seems like a good idea. And now with a bit of hindsight, it's like gRPC is really fantastic for doing like gRPC, distributed RPCs. But this is streaming, and we've really kind of
it's not for
like
bulk data transfer.
It's not for, and we're like really wrapping things within things in a really inefficient way. Where all we need is TCP packets. And so
I didn't even mention this, but this backchannel Gitly thing adds another level of wrapping. So when Prefect talks to Gitly, it's not straight RPC. It goes through a library called Yamux, which is made by HashiCorp. So there's even another layer of wrapping going on before the data goes out. I don't think that layer is super inefficient, but it's yet another layer. And one thing I try to achieve in this with this toy thing, and I try to work into the design, is to end up in a situation where first there's an exchange between the client and the server about what are we going to do, and then all that stuff gets out of the way and you just get a connection. Like I want 0 layers in between, so that we have the maximum opportunity to do whatever. Yeah, so we can go as fast as possible. So I'm trying to avoid layers. And yeah, no, I'm definitely not saying we should throw gRPC out, because it works great and we have so much work invested in it. There's no way to justify replacing all we did with gRPC.
There's certain things where it like further refinement makes more sense than just like carrying on with that approach.
Yeah, thanks. Yeah, that's the gist of it. Yeah. Well, thanks for letting me talk about code as you for 15 minutes.
Can I ask you a quick question before moving off the topic?
Yeah.
So with reading through your thoughts on how you're going to get there, and that whole issue where you've been writing up all of your notes, like at what point are you going to like just write up the conclusion? Like I'm trying to figure out how much further you're going to take it before you say, right, this is the conclusion. And will you get there before you go on leave?
I think I should be able to. I find it difficult to get this out of my head, because I have it all worked out in my head, but that's no good because nobody can look in my head. So for me, it's a challenge in somehow getting it out of my head. But the way I've been approaching it is just pulling different threads out of my head and starting an issue thread and writing that. But I think I'm running out of threads in my head, so I come to the point where I can just say, this is the top line summary of the proposal, and if you want to look at the details, they're all down below. And yes, I think I can do that before I go on leave.
Great, thank you. Because then we'll be able to take that the proposal and the idea and figure out how we'll slot that into the workload that we have and when it would be right to pick it up.
Sounds good.
Well, Andrew, you've got the next one.
Okay, just before I do that, I thought I would write that mechanical sympathy alert for the SQL N+1s, because we don't have one. And it uses, it's not like single values. It uses like a P95 of how many requests a call makes to the database. And we've got some rather bad things taking. The worst seems to be 475 P95 per request, which is pretty terrible, and I'm looking forward to putting that in. So I'm going to start creating infradev issues around that. And actually in that one, the worst it does is 1,000 per request, but that's the max in the last hour. So that's kind of an interesting side thing. I just wanted to this is kind of not on any agenda, but it's something that's been bugging me as something that we need for a while. And what it is that we set the SLOs on our SLIs, and we aren't very good at reviewing like how those SLIs are performing according to those SLOs. And that creates unhappiness because some things always alert because they're basically under. And then the other thing that happens is that some things are just so far off their like normal value that when things go wrong, we don't trigger because the SLOs were set when, you know, there were different requirements or the software was different or there was some bug or something like that. And so I was talking to Java about it, and what I was thinking is like once a month, like in some channel, there's a message that comes up. Please remember to review the SLOs, and it can give you basically the last 28 days because I think that's our standard now. And it says over the last 28 days, this SLI has this component has had this availability, and this is where the SLO is, and then you can see how far up or down it is. And so I just created a little dashboard for that. Let me just share my screen. It's not very exciting, but it's more like I'm trying to figure out how to make a process around that. And my computer's been acting really weirdly when I've been using Zoom recently. So let's see if it works. Yeah, it's basically not working. Am I even coming through on Slack?
Yeah, I can see and hear you.
Let me try a smaller screen.
Andrew really wants to do computer.
No, I'm waiting for an M2. That's my
Get an Intel. Get an Intel while they still exist.
No, dude, I want to have endless problems with Homebrew and Docker. Like that's what I live for. So I'm going to wait for an M2.
That's why I put Homebrew in a non-standard location, because I love that stuff.
So let's just yeah, that doesn't sound like a great idea, Sean. Let me just try
it works
this
fine
one
for
browser.
basically everything except building Git, as it happens.
Okay.
And even then, it's not hard to work around.
So it's not very exciting, but it's not meant to be very exciting. Can you see my screen now? So can anyone hear me?
Yep.
Yes.
Okay, good. Okay. So basically what it is it presents it as like how under or over the SLO the thing is. And so what we've got here is this. There's no big surprise there. It's basically 9% under the SLO, the shared runner queues, because of all the problems that we've had in the last few weeks. The problem with that is it's actually very difficult to make it any lower, because basically we're getting outside of the realm of when SLO mathematics works any longer if we make it any lower. So that's pretty much going to have to be a silence, unfortunately, until things get better. But then with some of these other ones, we tend to sort of be sitting very, very close to the threshold, and maybe we should push them up. But I just thought it would be kind of interesting to build this little dashboard. This Thanos compactor, I think I'm going to remove because it almost seems to never run it. We get very, very sporadic data, so I don't think it's worth even having in here as well. It's also an outlier. But kind of what I was imagining is we do a review of this and we basically adjust the SLOs according to where the data is, so that, you know, we're alerting on unusual behavior. We're not alerting on like services that are just running poorly, and, you know, infrastructure don't have anything to do with it. So what I want to do is take a look at this and then update the SLOs on a monthly basis, or maybe 2 months, or however often. But there's two things that I think we have to do before we can do that. And the first is that I think we need to give each SLI its own SLO, because at the moment we set the SLO at the service level and the SLIs all have to be the same. And what we find is that they're actually quite different. and there's no real reason why they should all have the same SLO. And so that's one change that I think we should make before we do this.
Why would you do that? Like, not that it's wrong, just to understand. Is because I was looking into separating out API, like GraphQL from the API, because they just look different. But I would like, my initial thought was to put the thresholds differently inside the apdex for both SLIs, rather than setting a different SLO for them.
So sometimes we can do that, but it depends on the histograms, right? Because like some histograms are like, 10 seconds and 30 seconds, and you can't do fine-grained adjustments on those without changing the application. So sometimes you don't really have great things on that. But that's, so if we take a look, this, by the way, clicks through. So if you go take a look at, like the Sidekick one is a pretty good example. Like the Sidekick queues are all kind of different from one another, and maybe they need to have different SLOs. But if you click on this, it actually opens up this Slo Analysis Dashboard, which is quite useful. So you can see how the data's been historically once it loads. So that's where it is at the moment, 99.5. And then, we were 1.3% below that, actually over the month. However, there's another part to this, and that is that we're only evaluating on the 1 hour and the 6 hour thresholds. And in order to make this fair, we should also be evaluating on like the 3-day 10% threshold. To say that this one as well is also super sporadic. So I might come up with a way of filtering out, this database queue only runs when there's certain types of database migration. So it kind of isn't a very good one to use in the review or in a demo. Well, my computer's, I don't know, I can't really do anything now. So I'm going to just stop sharing my screen again.
Could you link the dashboard you just showed in the doc?
Yeah. It's still as a merge request, but the only reason I pushed it to Grafana is because I wanted to edit it and play around with it. So it's a official, unofficial dashboard. So I'll send you. I'll include you on the MR, Bob. But the two things I think we need are the longer, are the 3-day things going to issues, not paging people, and then also the multiple SLOs. Yeah. Well, I'm kind of worried that might be a bit complicated. Like there's a lot of things that you have to kind of measure then, but yeah. Cool, and that's it.
Was there anything else that anyone would like to talk about or share? Great, then thank you all very much for the discussion today. I hope you have a good rest of your day. Bye.
Bye, Amy.
Say bye.
Bye.